Hi everyone, my name is Hannah Licklider and I will be covering Module 1, British versus French engineering. French engineering really stems from the needs of the military and national government. Due to France being a centralized state, the king was able to pull tax revenue and military manning from across the country to support engineering projects. The Corps of Engineers in 1676 was created, and all men who joined were military engineers who were provided training. The French also created some of the world's first schools of engineering, which employed math and theory in its practice, something that set French engineers apart from British. The British approached engineering as something that you make work, not something that you know why it works. They relied heavily on the job training and apprenticeship as opposed to formal training in universities. The key difference between the British and the French is that the French were know why, the British were know how. After the United States won their independence, they had to focus on growing its economy. 90% of Americans during this time were farmers who sold their goods to their local community. This was not profitable for the U.S. Additionally, westward expansion had started as the young government was looking to expand their country as a whole. This turned many to the idea of building canals. Canals could be used as a means of transporting goods from the eastern states to the western states, creating a larger market for farmers and craftsmen alike. The Erie Canal became the engineering project that solved this problem of getting goods from the east to the west and vice versa, in an efficient, cost-friendly, and profitable manner. This idea was not met with a lot of enthusiasm due to the previous canals, such as the Middlesex Canal, not turning a profit and being quite complicated to complete. The Erie Canal, no one in America had any experience. New York had appointed 3 judges and 1 teacher to head the project. These judges are Benjamin Wright, James Geddes, and Canvas White. All men had little training in engineering and were successful in completing the Erie Canal by practicing their surveying and constantly making changes until it worked. British. Those who dug the canal had the hardest work of all. The work was backbreaking and in environmental hazardous areas that resulted in thousands of deaths due to disease. Construction began in 1870 and ended in 1825 with the wetting of the waters, and it ended up running 353 miles from Albany to Buffalo, New York. Schools of engineering. The Erie Canal is often referred to as the first school of engineering. Those who worked on the canal had little to no training on how to build a canal properly, and many who became great engineers later in life had started as axemen on the Erie Canal. John B. Jervis was one of these men. The Erie Canal is a school that was heavily influenced by the British tradition. West Point was created as the first school of engineering that was modeled after the French tradition and schools. The Army Corps of Engineering was created in 1779, and men that were sent to this Army Corps were then sent to West Point for their formal training.
Thank you, Hannah, for your presentation on the Erie Canal. My name is Justo Morales, and I'm going to be presenting next. A key development to the engineering profession in the late 19th century was professional societies. The need for them was because engineers initially did not get respect. It wasn't a profession that was held in high prestige. And so societies actually legitimized the profession of an engineer. The strategy that these societies took was, one, AIME actually included everyone in the industry. 2, ASCE, they actually selected individuals who could contribute to the fields. ASCE actually had an ethical code where they actually monitored the activities of members, and they had tried to ensure that they benefited society. On the other hand, AIME actually supported business practices, and they saw the engineer more as a businessman than a professional. Another development was women and minorities, because in the late 19th century, women minorities were excluded from the profession. At the time, only a small segment of the population became an engineer. This was even more so apparent in the engineering than in other STEM fields. All the other STEM fields actually had better representation of women and minorities than did engineering. And some of the reasons that they gave is that women were actually too weak. They were not smart enough for technical work. They would distract men if they were co-workers, and they were barred from schools of engineering. Minorities also, or similarly, because they were slaves, they were not considered engineers. They also suffered a lot of discrimination. Their primary schools for African Americans in the 19th century was actually inferior, and they were barred from higher education. But some of the exceptions that actually were able to overcome and become engineers. From the women, we actually have Emily Roebling, whose husband was an engineer, and so she did a lot of the work for him. Kate Gleason was the daughter of a machine shop owner, and Nora Stanton Blatch Burney was actually a Cornell graduate. From the minorities, there was Benjamin Benneker, who was actually self-taught. He published several almanacs. And then we also have Elijah McCoy, who actually obtained 50 patents for his oil lubricating devices for the railroads. So there you have it. Let's go over to Sam now.
Hey everyone, I'm Sam, and today I'm going to talk about Unit 3. Today's topics are the linear model, professional and non-professional inventors, and industrial research laboratories. So basically, the linear model assumes that innovation is applied science. It's linear because there's a well-defined set of stages that innovators are supposed to go through. Research, which is science, comes first, then development, and then finally, production and marketing. Since research comes first, it's easy to think of this as the most critical element of the whole process. Really, the linear model is flawed because its explanation of the innovations process, because it overlooks the extent to which practical tinkering has produced many of the critical technologies and breakthroughs. Besides, attempting to understand why technologies work has often been the incentive for advancements in science. Basic science definitely is not the fundamental driver of technological innovation. Let's take, for example, some of these inventions. Francis Bacon invented the compass, gunpowder, and the printing press. Thomas Newcomen with the steam engines, and he also had little to no idea about the underlying science of vacuums or pressure. Henry Ford with the internal combustion engine had no formal education as well. And in iron production, they thought it was a temperature of the environment that was beneficial in producing iron. That's a better quality. But it was actually the lack of humidity that was due to the cold weather. Many pioneers have discovered how to make electrical equipment work in advance of proven theory in the electrical industry. Countless scientists made these functioning inventions their topic of analysis to figure out why and how these work. So, why does linear models persist? Well, it benefits science. For one, it's a great way to retain funding for science, which many people think is important, which is for reasons other than inventing. Also, it has benefits for engineering because it links engineering to the science realm. Independent inventors such as Thomas Edison, Nikola Tesla, the Wright brothers, and Alexander Bell played an instrumental role in the technological revolution of the 1870s through the 1915s by creating inventions that signify this unprecedented period. These independent inventors share multiple characteristics. Many of them grew up in rural areas and had little to no formal education. They also had to face the challenges of the inventors of that time by raising money. Full-time inventors, such as Edison and Tesla, needed to market their designs to financiers, like J.P. Morgan, to secure funding.